Hello everyone, I'm Associate Professor T.S. Dr. John Siat Ling from FKE UTHM. Today I would like to share with you a topic on discrete time signal operation. The learning outcome of this topic is, at the end of this topic, students shall be able to solve discrete time signal operation. Discrete signal operations consist of time shifting, folding or inversions, time scaling, additions and multiplication. The first discrete signals operation is time shifting. Time shifting means moving a signal left or right along the time axis without changing its shape. So if we have the yn equal to xn minus beta, for beta more than 0, it means it moved to the right by beta unit. So if we have yn equal to xn plus beta, for beta more than 0, the signal is at once. So it moves to the left by beta unit. You may think like this. Right shift is equal to late. Left shift is equal to early. So the signal look exactly the same, just happen earlier or later. Do you get it? Second is folding. Folding means flip a signal around n equal to 0, just like looking at it in a mirror. So if we have a signal yn equal to x minus n, it is the mirror image of xn, so across the vertical axis. So we also can combine the folding with shifting. For example, you shift first, then fold. So you will have xn. If you shift first, so you have xn convert to shift, then xn minus beta. Then fold. So xn minus beta to x minus n minus beta. If you do the folding first, so xn to x minus n, then shift by shift left by beta units. So that will be minus x minus n plus beta, or you can say x minus n minus beta. Now let's look at this example. Given xn equal to 2, 3, 4, 5, 6, 7, where the origin at number 4, okay, origin at the value of 4. So find and sketch the following questions. For the first question, given the xn equal to 2, 3, 4, 5, 6, 7, and this is the origin, the value with 4. Okay, so now this the question is xn minus 3. This n minus 3 means delay. So you need to shift the graph 3 unit to the right. So this is the graph. You need to shift 3 unit to the right. So start from, for example, I take the first value here. So 1 unit, 2 unit, 3 unit to the right. So now the first value is here. Okay, so this means if you look at here, it is at the n equal to 1 here. So this is the first value. So if you write the numeric sequence, that will be 0, 2, 3, 4, 5, 6, 7. The origin must include, so that we know that where is the origin value. Alternatively, we also can shift this kind of question by shift the origin symbol. For example, here, if you look at this xn minus 3, so minus 3, this means you shift the origin value, origin symbol here, 3 units to the left. Okay, so 1, 2, 3 here. So the new origin at 0 here. So this value, this alternative value is this alternative method is quite straightforward. We can shift the graph. This method is to shift the origin symbol. Second question, fn equal to xn plus 2. So this n plus 2 means at once. So shift the graph 2 unit to the left. So this is the graph. 2 unit to the left. Okay, I can start from the rightmost value, which is n equal to 3, 2 units to the left. So I shift 1, shift 2. Okay, so 2 units. So my new location is start from here, n equal to 1, which is exactly like this. So where is origin? Origin at here. So you have from 2, 3, 4, 5, 6, 7. The value is from -4 to 1. So make sure you put a origin symbol at the numeric sequence, in which the value with 6, like this. Alternatively, you also can solve this problem by shift the origin symbol. Okay, so for example, this xn is 2, 3, 4, 5, 6, 7, and the question is n plus 2. So this means you need to shift the origin 2 units to the right, plus 2. Okay, 2 units to the right. So it's from 4 to 2 units, 1, 2. So you get the 6. So this is quite straightforward rather than you need to draw the graph. Okay, so how to remember? For example, you can remember like this. If you have plus 2, okay, if you have plus means you take the origin symbol, you shift to the right. If minus, you shift the origin to the left. That's easy for you to remember. Okay. The third question is about folding. So the question like this: Gn equal to x minus n. So this minus is referred to the folding. So folding means mirror image at y-axis. So like for example, you put a mirror, okay, at the y-axis. So if you look at the numeric sequence 2, 3, 4, 5, 6, 7. So the value change the location only. We cannot change the origin. Origin must remain the same. Okay, just like this one. Okay. This question requests you to find the hash n equal to x minus n plus 1. There are two methods that can be used to solve this problem. So I use the for first, then time shifting in these solutions. So first of all, I for xn. So for xn, this means this is the mirror image at the y-axis. So I can write it as x minus n. Okay, then the numeric sequence is just like the original value xn, but the for version is you just change the locations from the left to the right, from the right to the left, without change the origin. So origin remain the same. Now I get 765, 432. Next is the time shifting. So if you look at here is x minus n plus 1. So since the delay have been done before, next is the delay. So for the delay, I need to bracket, okay, bracket the value of this one. So negative n plus 1 change to negative the bracket n minus 1, like this. So this one is a delay by 1. So I use the method of shift the origin symbol. Okay, so delay by 1, so shift the origin symbol 1 unit to the left. So it's from 4 to 5, so 1 unit. Now I get this value for the hash n. Alternatively, you can solve this problem. Use the time shifting first, then followed by folding. Okay, the same questions. So if you do the time shifting first, so that will be directly you take n plus 1, xn plus 1. So xn plus 1, you shift the origin symbol to the right 1 unit, then you get this value. After that, you do the folding. So folding means it's x minus n. Okay, it's a mirror image at the y-axis. So folding, you just directly flip, okay, flip this signal without change the origin. Just change the left hand side signal to the right hand side signal to the left. then the answer will be like this. Okay, this is a figure. So I would say the alternative is quite straightforward, alright? But it's up to you whether you want to use the shifting first, then fold, or fold first, then shift. This all fine as long as you can get the answer correctly. Here is another similar type of the questions. Find the Sn equal to x minus n minus 2. So in these questions, I solve using the fold first, then time shifting. Okay, so for the folding, so folding of the xn, this is the mirror image at the y-axis. So it's x minus n. The mirror image, this means that the left move to the right move to the left, we got change the origin. So it start from 7, 6, 5, 4, 3, 2. Origin still remain at here, value 4. Okay, after that is the time shifting. This is time shifting. Okay, if you look at the question, minus 2 minus n minus 2. This means that you need to, since this is a folding you have done before, so you need to bracket it out. Then you get minus in the bracket n plus 2. So this n plus 2 is an advance by 2 units. Okay, advance by 2. So I use the origin symbol technique. Then I shift the origin 2 units to the right. Okay, advance is 2 units to the right. So I get 1, 2. The end, I have the origin at the value of 2. Here I also show you an alternative to solve this problem by using time shifting first, then followed by folding. So if I do the time shifting first, this is n minus 2, is a delay. So delay by 2, I use the origin symbol method. So I shift the 2 unit to the left. Okay, for the delay, I shift 2 unit to the left. So the symbol of origin is here. After that, followed by folding. Folding is the mirror image at the y-axis. So I fold it. Okay, I fold it. So all the signal on the right will change to the left-hand side, will move to the left-hand side. So that's why I get 7, 6, 5, 4, 3, 2, origin at the value of 2. Now we look at time scaling in discrete signals, which change the number of samples in the signal. There are 2 main operations, decimation and interpolations. For decimations, we reduce the number of samples. So some samples are discarded, so the signal becomes shorter. Whereas for interpolation, we increase the number of samples. New samples are inserted between the existing samples and the signal becomes longer. So remember, decimation is fewer samples, interpolations more samples. Remember that xn is actually the continuous time signal xt, sample at every ts second. Now let's look at this signal. Yn equal to x to n. This means that we only take the x0, x2, x4, and etc. So we are taking the alternate samples of the original signals. So because of this, the signal looks compressed in time and the number of samples becomes smaller. So this process we call it as a decimation or downsampling. So in general, decimations by n means sampling xt over every nts, so which reduce the sampling rate by n times. For the interpolation of time scaling, still remember xn is the continuous signal xt sampled at every ts. Now consider yn equal to x, n over 2 is this means that we are sampling xt at a smaller interval at ts over 2. So as a result, the signal has a twice number of the sample. So one new sample is inserted between every two original samples. So this process is called interpolations or upsampling. So if we know the exact expression of the xn, we can calculate the new value easily. Otherwise, we estimate the new value by interpolating between the existing samples. When we insert new samples during interpolations, we must decide the value of these new samples. So there are several simple methods such as the zero interpolations. So zero interpolation means insert zero between samples. Next is a step interpolation. Step interpolation is insert a value equal to the previous sample. And lastly is the linear interpolation. So this interpolation insert the average of two adjacent samples. So all these methods help us to estimate the new sample value when the exact signal expression is unknown. Now consider two sequences of operations. First sequence is the Sn, then decimated by 2, you obtain x2n, then interpolated by 2, you to obtain xn. Then second sequence, interpolated by 2, you get xn over 2. Then decimated by 2, you get xn. So at first glance, both seem to give back the original signal xn, but it looks like decimation and interpolation are inversely operations. But actually, only the second sequence, means the operation first, then decimation, can recover the xn exactly. Do you know why? Guys, do you know why? Because when we decimate first, some samples are permanently lost. So interpolation cannot recover those lost samples. That is why only the second sequence can recover exactly. Example 1.5, given the xn equal to 12648 and the origin at the value of 1. So calculate two sequence of operation by using step interpolation xn over 2. So this is the hints of the operations. You have 1, then interpolation, 2 interpolation, then 6 interpolation, 4 interpolation, then 8 interpolation, then 0. So what is the value of this one? Now let me show you what is the answer if we do the decimation first, then interpolate. Okay, first we decimate by 2. So we shorten down the signals. We take every two samples. So 168. Okay, 168. After that, interpolate by 2. So by step interpolations, so you have 116688. Okay. Then the next one is if you do the interpolation first, then decimation. The same signal given, then you interpolate first using step interpolations. So from here you have 1122664488. After that, you decimate by 2. So you take the sample from every two samples. So 1, 2, 6, 4, 8. Okay, now you can see that the answer from A you have 116688. The answer from B you get 12648. So which one can recover the signal Sn? This one, right? This one, the final answer is the same with the original questions. So this one, sequence 2, can recover the signal of Xn. Fractional delay. Sometimes we need to delay a signal by less than one sample. So for example, a half sample delay. So this is called a fractional delay. And we cannot do this by simple shifting, so we must use 3 steps. But remember to follow the order such as interpolation, shift, and decimations. So this is the order that you need to follow. So interpolations means you interpolate the signal by a factor n, So this interpolation increases the number of samples. While for the delay, you delay the signal by m sample at the higher rate. And for the decimations, you decimate by n, and this return to the original sampling rate. Again, look at this example. Given xn equal to 2468, where the origin at the value of 6. Calculate the signal yn equal to xn minus 0.5 using linear interpolation. Okay, the questions given is the xn equal to 2468 and calculate the yn equal to xn minus 0.5 using linear interpolations. So first of all, we need to change this xn minus 0.5 into this format. X to n minus 1 divided by 2, because 0.5 is actually 1 over 2. And then if we want to change to a numerator and denominator, so we need to change in this format. Okay, if we cancel out, this remain n minus 1 over 2. So we change to this format first. Then do remember the 3 steps have to follow the sequence, which is interpolate by 2, delay by 1, then decimate by 2. Okay, now let's look at the linear interpolations. So the questions request for the linear interpolations. Okay, so linear interpolations by how many? By n over 2. Okay, these two, n over 2. So it means that it interpolate by 2 from the numeric sequence here. So if interpolate by 2 means 2 to 4, you have the interpolation, one interpolation here in the middle. So linear, that will be 2, 3, 4. Then 4 to 6, there will be 4, 5, 6. 6 and 8, there will be 6, 7, 8. Then last sample is interpolate to 0. There will be 8 and 0. So 8, 4, 0. Okay. So this is the answer from the linear interpolations. Then after that, followed by a delay by 1. Okay. So the delay that will be here, delay by 1, gn minus 1. Okay, delay by 1. So if you take the origin symbol, okay, method that your origin move 1 unit to the left. So now your origin is at number 5, value 5. Then lastly is the decimations. So decimations is xn minus 0.5. Then there will be at the end is the 2n. Decimation is this part, 2n here. So 2n based on the latest numeric sequence. So which value should I take? You should take 2, 4, 6, 8 or 3, 5, 7, 4. Which one? Okay, the answer is you have to follow the origin symbol. All the answer must include the origin symbol. So therefore, you take these symbols. You take this value 5 from the origin. Also, you take the 3 because it's the decimation by 2. Then after that, you take the 7, you take the 4. So end up is 3, 5, 7, 4, and the origin is at the value 5. Do you get it? Discrete signal operation is the addition. Addition of 2 or more discrete signals are carried out by adding the discrete signals amplitude for every n value. Okay, so example, solve the x1n plus x2n. So if you have the x1n is negative 1, 2, 6. So make sure you arrange the table. Okay, follow the origins. Okay, follow the origins. So origin is at 0. Negative 1, 2, 6. So you arrange here, negative 1, 2, 6. Make sure the 2 is at the origin. Similar to the x2. So 3, 1, 2 at negative 1. So origin is 2 here. This one. So 3, 1, 2 at negative 1. Then you sum up. That will be equivalent to yn. discrete signal operation is the multiplications. So multiplication of two or more discrete signals are carried out by multiplying the discrete signal of amplitude for every n value also. So similarly, you have the x1 multiplied with x2. Again, you start with the put a table form, and then where you have the n value from -2 to 2. Okay, make sure you arrange, you know where is the origins. Okay, from the questions, -1, 2, 6. You arrange in this way, -1, 2, 6, and then 3, 1, 2, add -1, and then you multiply. Okay, you multiply. Then this is the answer after you multiply. Alright. Thank you for watching. If you like my video, please hit the like button at the YouTube video. Thank you.